The patient is prepared for the operation. Now the endoscope is collected from the rack and introduced to the patient. The robot is moved into position for docking with the endoscope. The two are connected, and now the position can be adjusted via the RoboCommander. Fine adjustment can be performed with the ring. Now the trocars are introduced to the other two ports in the body. And the robot drives to its preparation position. The assistant performs a motion test of the instrument holder. And now the robot can be attached to the trocar. It's driven into position with the RoboCommander, and now the trocar is clipped into the trocar holder. The position of the trocar can be adjusted slightly. And then fixed, so that the tool can now be introduced to the body. It can be driven in and out by pulling on the RoboCommander, and fine adjustment performed by twisting the ring. And now you can see the robot moving around the trocar point, which is fixed. In the main picture, the orientation remains constant, while in the side view, the rotation is changed. Here we see another view of the same operation, first with a fixed rotation, and now the tool can be moved in and out, and the trocar holder holds the trocar still. Fine adjustment is again performed by the ring. Now the trocar roll is changed, which allows a repositioning of the robot, and then fixed again, and the fine adjustment performed. Once all the robots have been docked, the operation can start. The surgeon sits at the console and is free to move his hands as and where he likes. If necessary, it is possible to declutch the instruments and move the hand to a completely new position. In this case, a simple demonstration of suturing is being performed. The system, as you can see, is made up of two robots holding instruments and one holding the endoscope, from which the three-dimensional picture is displayed in front of the surgeon. This could be extended to 4 or 5 robots if necessary. And our trainee surgeon has almost managed to tie a knot. Here we can see the input devices are stored and now picked up by the surgeon, who aligns them quickly and can proceed with the operation. The alignment procedure has been significantly simplified since the earlier versions. As you can see, it was very possible to very quickly begin operating. In this case, the surgeon has lifted his hands well off the elbow support, but it would be possible to reposition the input device and then continue the operation from a more comfortable position if required. Again, tying a knot here. And the 3D display allows him to judge the distance. Now we do another manipulation exercise of putting rings on the pegs. Again, without the 3D display, this would almost be impossible. The objects being manipulated here have different compliance. So some are made of rubber, which is relatively soft, and others are made of metal, which is obviously hard. This simulates the range of tasks that the robot has to perform. The input device is equipped with a force sensor, which allows the surgeon to vary the strength of his grip from either very lightly or to a very strong grip, as demonstrated here. Now we see a demonstration of the camera tracking function, which is intended for the laparoscopic market, principally in Europe and places outside the United States. Here, the surgeon is using a laparoscopic tool, and the endoscope is automatically tracking the position of this tool. When the rectangle identifying the tool moves out the central rectangle, the endoscope driver is compensating for the motion and follows it. It also tries to keep the size of the tool constant within the picture, which leads to an automatic zooming function. At this point, you can see the motion of the robot as it moves in and out. The next feature is the collision prevention algorithm. Here it is possible to move the robots to a certain distance from each other, but then the motion is stopped. The form of the robot is accurately tracked. In this demonstration, the distance was set to approximately 2 inches. Here you can see it is hard to push the robots together, but easy to push them apart. Again, hard to push together, but it can be easily pushed in the other direction. After the operation, the robots and the tools are extracted from the patient, and the robots can drive back to their parking position. Thank you for your attention. We hope you have enjoyed seeing the new features of Lisa, the surgical robot from RG Mechatronics.